Hi, Math 150. This is a test to see if the videos I make are going to help or not while we're in this unusual period of online teaching and learning, and large groups can't get together because of the coronavirus scare. So here it goes. I'm looking at our first exam, question 11 in particular. Many of us had trouble with that one. So we're going to see if we can't go over that together here, or if I can't go over it for you and make sense of it. It was solving this equation, 4b to the fourth power plus 10b to the third power equals 6b to the second power plus 15b. Now, on the exam, many of us divided the entire equation by a common factor of, say, b. And that's a bad idea to divide an equation by a variable factor because you lose zeros that way. You lose solutions to the equation. For example, b equals 0 actually solves this. It's one of the solutions. If we plugged in 0 for every term, we would have 0 equals 0, and that's a true statement. So b equals 0 is a solution. If we divided through this equation by b, we would just lose that solution. So do not do that. Instead, what we're going to do is, because the degree of this equation is higher than 1, it's a polynomial equation that's not linear, we're going to move all of the terms to one side of the equation and leaving 0 on the other side. So I'm going to go ahead and move the 6b squared and the 15b to the left by subtracting them. And if we do that, we have 4b to the fourth power plus 10b to the third power minus 6b to the second power minus 15b, and there's a b in there, is equal to 0. Now, the first rule of factoring is looking for a greatest common factor. And there is one that's not 1. It's b is common to all the terms. So we can factor out that b. And if we do that, that leaves 4b to the third power plus 10b to the second power minus 6b minus 15 is equal to 0. All of the powers of b went down by 1 when we divided the b out of there. Now, there's 4 terms in the part that's in parentheses there, the factor that's in parentheses. And we can factor by grouping. We can group the first 2 terms together, as well as the last 2 terms together. And we begin factor by grouping. That first b is always going to hang out there. It's one of the factors. It never goes away. But the factor that's made up of 4 terms, I can factor out of the first 2 terms here, 2b squared. And if I do that, I'm going to be left with 2b plus 5. Out of the second 2 terms, if the leading term in the second grouping is negative, you should definitely factor out a negative. It looks like we can factor out negative 3. And that also leaves me with 2b plus 5 equals 0. So the entire set of terms in there is set apart by a parentheses, and also inside we've also factored or done the first step of factor by grouping. You'll notice that what's in parentheses that I underlined is exactly the same. So we can treat this first part as a term and the second part as a term, and notice that the 2b plus 5 is in common. Well, we can factor that out. If we factor out 2b plus 5, then we're left with 2b squared minus 3 is equal to 0. So we divided out the 2b plus 5 from what's in the outer set of parentheses here, and that leaves us with the 2b squared minus 3. Well, we have a product of 3 factors that equals 0. One of these factors has to be 0. So b equals 0. There's one of our solutions. Or 2b plus 5 equals 0. And if we solve that quickly, that implies, by subtracting the 5 and dividing by 2, that implies b has to equal negative 5 over 2. And for the last factor, I'm going to move to a, maybe there's some room here that we can try this. Or 2b squared minus 3 is equal to 0. If I solve for b squared, by adding the 3 and dividing by 2, b squared is equal to positive 3 over 2. We want the 2 square roots of 3 over 2 to solve for b, because square roots undo squares. So that means b is equal, if I move over a little bit this way, plus or minus the square root of 3 over 2. Of course, we can rationalize the denominator by multiplying by 2 over 2. And that leaves plus or minus the square root of 6 in the numerator. The denominator is the square root of 4, but of course that is 2 because 4 is a perfect square. So there are our final two solutions. If I write this in roster notation, where we list the solution set out, the 4 solutions would be negative 5 over 2, negative square root of 6 over 2, 0, and positive square root of 6 over 2. And we're running out of space in this paper, but that would be the final solution.